Hi everyone, welcome to the Polynomials summary video. So we're in stage 5.3. We want to recognize, describe and sketch polynomials and apply the factor and remainder theorems to solve problems. First of all, what is a polynomial? The examples on this side are examples of polynomials, and the ones over here are not. So an expression of x squared plus x to the power of 4 is a polynomial. The 2 and the 4 are non-negative integers, so positive whole numbers. So the non-example is if we have something like a fraction that can't be written as a whole number, a decimal, or a negative integer. So this one here is not a polynomial because of the fraction, the decimal, or the negative number. Example 1b. So this is an example of a polynomial. So an expression of 5x squared plus 3x plus 2. Again, the 2 and the 1 are non-negative integers. And remember, we would actually write 3x to the power of 1 as 3x, just using 1 to highlight the fact that it is a non-negative integer. Non-example over this side. So this expression is not a polynomial, so the whole thing is the polynomial. Because of this term, it's not a polynomial. Even though the x squared plus x cubed is okay, this part is not, so this whole expression is not polynomial. This part cancels it out. And just remember that if we have x to the power of 0.5, that means the square root of x, which is x to the power of a half. So you'll see this written each way, each of those three ways. Example 1c, another example of a polynomial. This is the notation that we use that highlights that the expression is a polynomial. 3x to the power of 5 plus 7x to the power of 4. So 5 and 4 are non-negative integers again. And this is the notation that we use for a polynomial. So this is the non-example. So this is not a polynomial. So we would not use the px notation with this. So again, this part cancels it out, and so does this. 1 over x can actually be written as x to the power of minus 1. So it has a negative number here, so it's not a polynomial. Next example, 1d. So this means polynomial x. So the variable that we're using is x. We've got 7x squared plus 3x plus 8. And I want you to state the coefficient of x squared and x. I want you to state the constant term and the degree of the polynomial. So the coefficient of x squared is 7. So the number in front of the x squared, what we multiply x squared by, is 7, and we call that the coefficient. So the coefficient of x is 3. When there's no x, this is a constant. So the constant term is 8. The degree of the polynomial is the highest index for x. So we have x squared here, we have x1. The highest number is 2, so the degree is 2. If we had x to the power of 5 here, the degree would be 5. So again, the degree of this one is 2 because we have x squared. So this time around, using this notation, we need to substitute in 0 for x and 3 for x. So on the right hand side, 0 gets substituted in for x. So 0 goes in for x in both examples, in both terms. So we get 0 squared plus 5 times 0 plus 6. and that is 6. When we substitute in 3, we get 3 squared plus 5 times 3 plus 6, which is 30. So that is it for today's video. There are questions that I would like you to finish and more notes to make. So please check Sector for that.